For the longest time, a disease like multiple sclerosis, or MS, felt like it just struck out of the blue, like incredibly bad luck. But what if it isn't random at all? Today, we're going to pull back the curtain and look at the hidden patterns that are totally changing how we understand this condition, right? So if getting MS isn't just a roll of the dice, then what is it? What are the rules? What factors are at play? That's the huge mystery we're going to start to unravel. Okay, first things first, let's just do a quick refresher so we're all on the same page. What exactly is MS? Well, it's what's called an autoimmune disease. Basically, your body's own defense system gets confused and starts attacking the protective shields around your nerves. Think of it like the plastic coating on an electrical wire. When that gets damaged, the critical messages between your brain and your body get scrambled. And here's where we make a really important shift in perspective. While every single person's experience with MS is unique, the clues to what causes it aren't really found by looking at just one person. The real breakthroughs, they happen when we zoom way, way out and start analyzing the data from millions of people to see the bigger picture.
So to see those giant, big picture patterns, you need a very specific set of tools. And this is where the work of some real-life disease detectives comes into play. That field is called epidemiology. And honestly, the best way to think about it is as the detective work of medicine. These folks don't treat individual patients, they investigate diseases across entire populations. They're trying to figure out why certain groups of people get sick while others don't. And when it comes to MS, their work has been an absolute game changer. So what have these disease detectives actually found? They've been hunting for clues, or what scientists call risk factors. Basically, things that increase a person's chances of developing MS. Let's dig into the evidence they've collected.
And whoa, this right here is incredibly revealing. You see that genetics plays a role, for sure. It accounts for about 30% of the risk. But look at that other, much bigger piece of the pie. A whopping 70% comes from environmental and lifestyle factors. It perfectly illustrates that old idea, that our genes might load the gun, but it's often the environment that pulls the trigger.
So what exactly are these environmental triggers? Well, the clues are pretty fascinating. They include things like where you live in the world, specifically your latitude. That connects to how much sun you get and your vitamin D levels. It even includes past exposure to really common viruses, like Epstein-Barr, the one that causes mono. And then you've got lifestyle choices, like smoking and obesity, which have also been shown to be key risk factors. And this is probably the single most important insight. It's almost never just one thing. It's the complex interplay, the combination of a person's genetic makeup with all these different environmental factors that comes together to create their own unique risk profile for MS. Now, when we take all of these individual clues and we map them out on a global scale, that's when the patterns become undeniable. This is where the non-random nature of MS really truly comes into focus. Okay, check this out. This shows the most famous pattern in MS research. It's called the latitude gradient. And the difference is just dramatic. MS is so much less common in places near the equator. But the further away you get into places like Northern Europe and North America, the rate just skyrockets. This is no coincidence. It's a massive clue pointing directly to factors like sun exposure. Let's put it side by side, because the contrast is so stark. High-risk populations, they tend to live further from the equator, they get less sun, and they have higher rates of certain viruses. And the low-risk populations, you guessed it, they're typically closer to the equator with way more sun. The patterns are just so consistent, they're impossible to ignore.
Okay, so we found the patterns, we've identified the clues, but so what? What's the point of all this detective work? Why does it actually matter?
It matters because this is how we get from clues to actual action. It creates a clear path. It starts when the epidemiologists spot a pattern, like that link to low vitamin D. That finding then pushes researchers to figure out why, what's the biological mechanism. From there, we can develop public health advice, and most importantly, it opens up entirely new avenues for prevention strategies and treatments. This quote just sums it up perfectly. Epidemiology turns the puzzle of disease into a roadmap for prevention. By understanding who is at risk and why, we can finally start to move from just reacting to a disease to proactively building strategies for a healthier future. If you found this useful, do us a favor and hit that subscribe button for more deep dives. And definitely let us know your feedback and what topics you'd like us to cover next in the comments. So I'll just leave you with this question.
MS is just one example of this kind of thinking. What other medical mysteries could we finally start to solve if we shifted our focus from looking for a single magic bullet cause to understanding the broader patterns of our health? The possibilities are truly transformative.